Hello directors, this week we are on week 12, which the topic is Polygon, and we start off with doing a little bit of warm-up, and so it's still the interesting integers concept. So this day, if you're following the handout, you don't have to follow the same numbers they're using, but they use number 10, and so that interesting integers handout will give you some ideas of what they could talk about with 10. I usually just let the kids go and start talking about 10. I write 10 on the board and I let them tell me things like, this is how we spell 10. This is how we write 10 in Roman numerals. This is how we write it in tally marks. They always like to do other languages if they know them. So things like that. The other thing we did though this week that was kind of fun is I just gave a sheet of just like printer paper to one sheet of paper to each kid, and then I have scissors enough for everyone in the class, and we folded our papers and kept folding them until we had these really small triangles, and then we cut out some shape that is meant to be a snowflake. And so while we were working on our interesting integer and shouting out our stuff, the kids were also kind of using their hands and trying to cut a shape and see what kind of snowflakes we could create from it. So it's just something fun to do to start off those first few minutes. So that's like no more than 5 minutes. Then we move onto the cover and spend no more than 10 minutes on this. So they're looking at the cover and you can say, what do you see? And the kids were pretty vocal about this, and they were excited to talk about the snowflake because they had just tried to cut some snowflakes and make their own snowflakes. And they would talk about the image. This is called Blue Winter by the Math team, and obviously we have a snowflake on here. And so one of the things to maybe mention or point out is that when you look at snow that's falling down in the sky, it looks tiny and white and insignificant. But if you were to put that under a microscope and look at it fully blown up, you would notice how much detail and beauty is in every single snowflake. And it just goes to show how much effort does God put into everything, and how nothing is insignificant and tiny and unimportant. Everything is wonderful and made in His way. So it's a great thing to do to just kind of relate that to how God sees us and how important we are. Okay, and then the other thing I mentioned is that all snowflakes are hexagonal, meaning that they have 6 sides to it. And that is just amazing that is actually the reality of it, and just how they're perfectly symmetrical. They have this rotational symmetry where they're rotational at their symmetry is the same at multiple points. So when you draw a line here, this side is the same as this side, and draw a line here. So you have these multiple points where you could rotate it and it's the same on both sides. So that's the rotational and reflectional symmetry. So reflectional meaning if you just did like one line across, and you could reflect that, and so you would have that as well. Or rotational is you could switch it over and twist it, and it's still going to be symmetrical, and twist it again and it would still be symmetrical. So that's rotational and reflectional symmetry. And then we have a quote from Mary Shelley, and I just put in my notes, Mary Shelley is speaking to the reality that math does not exist in a silo. We see math all around our world. Maybe this is a good time to talk about that whole seeing the unseen, seeing how they're doing with those booklets. And it's essential to know math in order to understand science. And yep, okay, so here I have remind them about seeing the unseen booklets. And then the reflection for this week, go ahead and read that. And then I put in the notes, our topic this week is polygons, and a square is a type of polygon. Edgar Guest discusses being more like a square. And then I said, so what polygon would you guys be? And so each of them had fun just kind of naming out what polygon they think they are and why they think they are that polygon, that shape. And then I said, any other thoughts on how this ties to polygons? And when we're done with that, we can move on to dialectic stage. So the dialectic, remind them where are we at so they can look down in their complex or monomial notebooks, see where we are for polygons, week 12, and they can check it off. And then they're breaking into their invention page. So the invention page has a lot of information about conversions, and so how units are measured. And so 5 common topics. The first common topic, compare the standard units for measurement. And so what I mean is, what type of units are we using when we measure different things? For example, if I want to see if a pool is warm enough to swim in it, what do I measure? And the kids should say temperature. And then if I want to see how fast I ran in a race, what do I measure? And they might say seconds or time, something about how the amount of time. If I want to see how far I can jump in a single leap, what do I measure? And they'd probably say distance, or maybe meters or yards or feet, something that is a distance unit. And if I need to test an electric wire that has electricity running through it, does anybody know what that's called? And maybe somebody will know amps and have the answer for that. If not, you can tell them. So that's an idea of how we use different measurements. So if I'm measuring my distance, I'm not going to give you a unit that's based on liquids, right? That wouldn't make sense. And then standard units, the SI units, this is pretty much a standard unit that is used worldwide. So everybody has accepted that these are the standard. And there's more in the companion if you want to learn about how they like came together and decided on this and put that together. It's kind of interesting. But these are the standard units. The circumstances of metric versus customary. So if you go to most of the rest of the world, they're going to measure their distance in meters. And so they're going to tell you your speed limit on kilometers, how many kilometers for a certain amount of time, versus we're doing things with miles. We use feet and yards and miles, but you go to other places and they're using the metric system. And the metric system is beautiful because it's divisible by 10 or multiples of 10, and it's a lot easier to calculate. And we have to make things complicated because English language, we love doing that. And then I told the story to the kids, and it is almost unbelievable because it is so crazy. So how do the circumstances of metric or customary unit change things? This is a crazy story. So NASA had built the Mars Climate Orbiter. And this project cost maybe about $193 million to do this project, to make this orbiter that's going to go around Mars and track information, take pictures, things like that. That was the goal for the orbiter. JPL is the navigation team, and they work a lot on all the space stuff, and they were calculating things with metric units. They were using newtons to measure the force. But Lockheed Martin astronauts, who do a lot of the building of stuff, provided acceleration data in English units using pounds. They didn't realize they were not using the same units, and the incorrect data actually caused the orbiter to go off course, and it was lost forever in space. So they threw $193 million down the drain because they didn't bother to make sure they were using the same units. Crazy. Okay. And I already talked about, so my next note just says that meters are easier to remember because if you have 1 meter, like a meter stick, if you have smaller units, you just have centimeters, or really small is millimeters. And if you have a meter and you're looking at big distances, then you're looking at kilometers. It's a much easier way to calculate things. And in science, we'll use meters pretty much for our calculations. And then the next thing for 5 common topics, relationship. So the relationship of conversion factors. How important is it to make sure you are converting things to the units that you need to represent or that you need to use? They do a ton of this in Math Map. So those word problems where they're having to convert things and then make sure they're getting it into the right units at the end, that's important stuff. I told the kids how I had my college professor for physics. Our exams would have like 3 problems and that's it. And you'd have this whole page of work that you had to do, and you'd have to do drawings, and you'd have all this stuff to show your work. And if you didn't put your units, he would mark the whole thing incorrect. And I always felt like that's so unfair. I just forgot to put something on my units. But if you think about it, so maybe on a physics quiz, it doesn't really matter much. But if I am building a space shuttle and I'm flying astronauts into space, I better have those units correct because people's lives depend on it. Or if I'm a nurse working at a hospital and I have to dose a pain medication to a baby and I give them grams instead of milligrams, I mean, that could have some serious consequences. So units are important, and that's why that relationship is important. And then the last question, who's the authority for standard units? You can look more on the companion if you want to read about that. We didn't really get to that in my class. We kind of focused on talking about those other things. And then the memorial arrangement page looks like this. You have all these shapes. A lot of this is familiar and friendly to the kids, which is a nice break after last week, which was a little crazy. So it's nice to say, okay, the shapes, things to notice about this. You don't need to have this all memorized, but let's look at what you already know. You know that shapes have names. If you have 3 sides to your shape, you have a triangle. When you have 4 sides, there's a couple different things you could have. Have you noticed the difference? What do you notice is the difference between those different shapes that all have 4 sides, but they all have different names? Why do they have different names? What do you notice about them? And then as we keep adding on sides, we get more sides to it, so more vertices. We also create more triangles. The triangle is the basic shape, and so when we're looking at our other shapes, we actually think about them in terms of how many triangles are in those other shapes. And so that's why you're seeing things broken down into their triangles. And that also makes it easier for us to calculate, because we know a lot of calculations for our triangles on those interior angles, all totaling 180 degrees. Well, you can apply that to all the triangles that you're looking at within those shapes. So that's why you get these equations that are kind of based on that triangle equation. If they want to look at this arrangement, maybe they just want to focus on starting to know the names for things. How many sides does it have? How many triangles could you create within the triangle? That would be something worth kind of starting to memorize or retain. And then just a little note, this scaling triangle right here, this is a Monomial booklet, and this is good. This is right. This one has 1 dash, 2 dash, and 3 dash. That's what they should look like. If they have an older complex triangle, it might have 2 dashes on one of those sides. Just have them fix it so that it's 1 dash. It's just one of the errata things. So wanted to point that out while you're right here on this sheet. It looks like the Monomials doesn't have that mistake on it, and the newer complex might not have it either. I don't know. Okay, and then the next thing, the key concept. So under the chart stuff, the key concept for the week, what is the definition of a polygon? It is a portion of a plane enclosed by straight lines. So you have to have straight lines. We are not talking about circles. We're going to talk about those next week. This week we are not talking about circles. We're talking about straight lines, and it has to be closed, meaning all of those sides have to come together. We can't have any part where we have an open gate. So everything has to be closed together to make the shape. And then next week we'll talk circles, and we'll talk about parts of the circles. And then when we come back from break, we actually talk about triangle shapes within the circles, because that helps us calculate some things. So that'll be coming up ahead in later weeks. The other thing is how triangles are a foundational shape to all these other shapes. And I just kind of talked about this a little bit. If you have kids that like to play, use tangrams and have the shapes where you have shapes and then you put them together to try to make images of other things. Or I also think of those little sticker books where you have a big page of stickers. A lot of them are triangle shaped stickers. And then you go back to your other page and you plot in your stickers, and then ultimately it makes an image of something. Those are really fun, cool math things for kids to play with, but it's also really good for learning tools, especially if you have a visual kid or a very hands-on kid, or if you want to bring that for your class. Instead of the snowflake thing, you have them just work on one of those sticker pages or something. That might be fun, and this would be a fun week to do it, and it would be a nice break after the kind of last few weeks of some heavy-duty graphing stuff. So this is kind of a nice breather week. And then in terms of the student pages, there's not really like a tops to the pages this week. The pages are like a full page of problems. So what I did is I divided it out. So I gave one student one part, one student this part, one student this section, one student this section. So everybody just got one section to focus on. We put it up on the board as much as we could, and then I let the students explain, this is how I solved this, or this is how this one was this. It ended up being a week where we had time for that, and I love when the kids get to use those rhetoric skills and teach that information that they just learned or that they just saw or figured out. And so this is a great week where they have that opportunity to do that. And I said if we have class time, work through some extra sections. I don't think we did in my class that week. And then just the run through the catechism. It should be pretty quick at this point in time, and hopefully they're knowing where to go to find information. And that's about it. So it's a quick, fun, hopefully familiar week that is just a great chance for the kids to kind of get a little refresher after some hard pre-calc type stuff, intro stuff that they've had these last few weeks. So this one is kind of just hopefully nice and familiar, and they really enjoy it. So thanks so much for watching.
Is your student easily frustrated with math? Are you worried a new math program will put them behind? Help your child navigate the math map by becoming a Math Explorer. Math Explorers is a supplemental program to assist with Math Map Complex or Math Map Monomials. This online program offers a weekly schedule, daily flashcard practice, daily video lessons and practice problems, weekly assessments, office hours, and more. Your student can watch from a desktop computer or through our app. Build their confidence, boost their retention, and set them up for math success with the Math Explorers program. A low monthly subscription fee makes it affordable, and you can cancel anytime. Visit mathexplorers.net.